You're chest deep in the ocean. You can't see your own feet. The water's that murky greenish color where visibility just dies after a few feet, and everything past that is guesswork. Somewhere out there, maybe 20 feet away, maybe closer, there could be something the length of a car, rows of serrated teeth, 400 million years of practice killing things in water. You have no way of knowing, and yet you'll probably get out, towel off, and never think about it again. Here's the part that should bother you more than it does. Hundreds of millions of people swim, surf, and dive in shark-populated water every single year. Worldwide, the International Shark Attack File, run out of the Florida Museum of Natural History, tracks every confirmed unprovoked shark bite on the planet. The yearly total usually lands somewhere between 70 and 100. Fatalities are typically single digits, out of hundreds of millions of chances. For an animal built nose to tail to kill things in water better than almost anything else alive. So why doesn't it happen more? There's no single answer. There never is. There are several, and they stack on top of each other in a way that's a lot more interesting than the mindless killing machine version you've absorbed from 50 years of movies. First problem a shark has: you don't look like food. Most of the species responsible for human bites, great whites especially, spent millions of years hunting seals and sea lions. Specific shape, specific movement, specific blubber content. A human swimming on the surface doesn't match that profile well. We kick differently. We move differently. We don't have the thick fat layer a shark's whole hunting strategy is built to detect. One big exception, and it explains a huge chunk of the statistics. Surfers get bitten far more than swimmers. The leading theory is silhouettes. A person lying flat on a board, paddling with arms moving on both sides, seen from underneath against bright surface light, can look enough like a seal to get investigated. Investigated, not eaten. Investigated. That word matters, because a huge share of confirmed shark bites follow what researchers call a bite and release pattern. One bite, then the shark disengages and swims off. Survivor accounts describe this constantly. One bite, then nothing. Gone. From the shark side, that's not mercy, that's math. A bite is also a taste test, and what a shark tastes when it bites a human is lean muscle and bone, not the thick, energy-dense blubber it's actually after. Wrong prey costs real energy for almost no payoff. Sharks that waste bites on bad targets don't out-survive sharks that don't. The mistake gets corrected fast, and the shark moves on to something actually worth the effort. There's also a detail that gets lost in treating sharks like one big undifferentiated threat. Over 500 known species exist. Most of them have never bitten a human and physically couldn't do real damage if they tried. Small, slow, bottom feeding, built for plankton and shellfish. The species behind nearly every serious bite narrow down to a short list: great whites, tiger sharks, bull sharks, oceanic white tips. Humans swim in every day will go their entire lives without ever biting a person. Bull sharks deserve their own mention here because they break a rule almost nothing else on this list does. Most sharks stay in salt water their whole lives. Bull sharks don't have to. They've got a kidney and gland system that lets them regulate salt balance well enough to swim up rivers, sometimes hundreds of miles inland, showing up in freshwater lakes and waterways far from any ocean. That alone makes them more likely to cross paths with humans in places nobody expects a shark at all. Combine that range with a reputation for being less picky about what counts as worth investigating, and bull sharks show up disproportionately often in attack statistics. Not because they're uniquely vicious, but because they simply end up near people more often than a species that never leaves open ocean ever would. Tiger sharks complicate the mistaken identity story a little too. They're famous among marine biologists for having unusually broad diets and unusually low pickiness, willing to investigate almost anything that might be food, including things that clearly aren't. License plates and tires have turned up in tiger shark stomachs. That curiosity cuts both ways. It means tiger sharks are more likely to bite something unfamiliar out of sheer investigative habit, but it also means a tiger shark biting a human is far less likely to be a calculated predatory attack, and far more likely to be exactly the same kind of test and release behavior described earlier, just from a species that tests more things in general. Sharks also run on senses tuned with frightening precision to one very specific kind of prey. Beyond smell and eyesight, there's a network of electroreceptors called the ampullae of Lorenzini.
built to detect the faint electrical field every living thing generates, plus a lateral line system that reads pressure and movement in the water around them. Over hundreds of millions of years, that system got calibrated to one signature: a fish in distress, a wounded seal, something moving in a way that screams easy, vulnerable, worth chasing. A human treading water calmly doesn't make that sound. You're not invisible. You're just not broadcasting the one signal this animal's entire nervous system is built to chase. Put the real numbers next to anything else happening at the beach and the fear starts looking strange. Rip currents kill more people in the US alone every year than sharks kill worldwide. Drowning, no animal involved at all, dwarfs shark deaths completely. Jellyfish stings send more people to the hospital every year than shark bites do. None of that makes the fear irrational, exactly. Sharks are genuinely formidable and the instinct is old. It just means the actual statistical threat in the water with you is almost always smaller than something else on that same beach. Cage diving makes this even clearer. Every year, thousands of people pay money to get into the water specifically to be near great whites, tiger sharks, sometimes with nothing but a thin metal cage between them, sometimes with nothing at all. Free divers swim alongside reef sharks and even bull sharks on purpose repeatedly as a job. If sharks were actually patrolling for any human-shaped opportunity, this entire industry would have ended decades ago in spectacular, headline-generating fashion. It hasn't. Operators get closer to large sharks than almost anyone on Earth year after year, and the injury rate stays remarkably low. Not zero. Low. Here's the biggest myth in this whole topic, and it's worth saying directly. A shark, like any large predator, runs a constant risk calculation because injury is a real cost. When there's no vet anywhere in your entire life, a human thrashing or fighting back can genuinely hurt a shark's eyes or gills, areas where there's zero protective padding. Add real injury risk to a bad energy payoff and easier food swimming nearby, and most sharks simply have no good reason to commit to a fight with something this unfamiliar. Now the honest part, because this video would be irresponsible without it. Attacks do happen. When they do, something's almost always unusual about the circumstances. Bad visibility, where a shark genuinely can't get a clean read on what it's approaching, shows up disproportionately often. So does fishing activity, bait, or chum, which scrambles the signals a shark normally relies on. One of the most famous cases in American history, the 1916 New Jersey shark attacks, killed 4 people along the Jersey shore in under 2 weeks. It happened during an unusually hot summer that pushed swimmers further out than normal. In an era with zero understanding of shark behavior and zero warning systems, researchers have spent over a century arguing about exactly what happened. What stays consistent across nearly every well-documented attack since is the same pattern that shows up with lions, with tigers, with every large predator anywhere. Something about the normal calculation broke. Bad visibility, scarce prey, confusing signals, an old or hurt animal working with fewer options. The baseline, leave the unfamiliar thing alone, holds overwhelmingly often. It's the exceptions that make headlines, which is exactly why they feel far more common than they actually are. Here's the twist that flips the whole topic upside down. You are far more dangerous to sharks than they are to you. It's not close. Human fishing, most of it not even targeting sharks specifically, kills an estimated 100 million sharks every single year. Bycatch, finning, commercial operations that were never built with sharks in mind at all. Compare that to single-digit human deaths from sharks worldwide, and the actual balance of predator and prey here is almost absurd. Species that survived multiple mass extinctions that existed before flowering plants did, are now in serious decline within a single century of industrial fishing. Not because they're hunting us, because we never stopped hunting them. At a scale nothing in 400 million years of shark evolution ever prepared them to defend against. So next time you're standing chest deep in murky water, unable to see your own feet, feeling that small flicker of primal unease, hold both things at once. The unease is honest. Something with that much practice at killing efficiently genuinely might be out there. But the thing you can't see almost certainly isn't deciding whether to eat you. It's running its own ancient math. Wrong shape, wrong signal, wrong risk for the reward, and choosing almost every single time to leave you completely alone.